Welcome back, scholars, to Mr. Honeycutt's math class. So we are going to now determine how the increasing and decreasing domains from a graph. So starting with, again, another real-world example. I'm really trying to work with the real-world examples here. So this is the S&P 500. It's a metric of kind of like just how the stock market is doing. Like when people talk about the stock market's doing this or that or whatever, one of the metrics that we have for the overall stock market is the S&P 500. And it's like basically the 500 largest companies in America. So when they're doing well, the stock market's doing well, et cetera. So this is from, basically, this is most of your lifetime. So here's what it looks like. So, you know, it's going down, going up, go down. Like what does that mean? Like things like that. That's kind of what we're talking about. Like, are stocks increasing? Are they going up? Are stocks decreasing? Are they going down? Especially in the world right now, that seems to be part of what matters, what's important. So this also is going to start incorporating a lot of calculus stuff. So the positive, negatives, and then this part, in particular the increasing, decreasing, maximum, you're going to be using these skills in calculus all the time because we're talking about change, and calculus is the mathematics of change. So just let you know, it's just a wee bit of baby calculus here. So basically the first thing you need to know about reading graphs when we're talking about increasing, decreasing, as we're reading a graph, we're reading it left to right, you know, just like we do with words. So you're just reading it from left to right. And then as we're reading it from left to right, hey, look at this. I'm reading it. I'm going to start at the very left. And as I'm going along with the graph, oh, hey, look at that. It's going up. And then as I keep going to the reading it left to right, oh, now it's going down. That means it's decreasing. Oh, it's going back up again. That means it's increasing. That's it, y'all. So the graph is increasing, decreasing, increasing. From here, it's increasing. And here, it's also increasing. From here, it's decreasing because it's going down. That's it. And I think the key thing is to remember is we need to be thinking of graphs not as static images, as individual shots, but you need to be thinking of them as almost like a freeze frame of something that's in motion, okay? Because variables move, all right? They are numbers that move. And if you keep thinking about that, I think the increasing, decreasing, increasing language will help you. But it moves basically from left to right. So let's look at these. So when is it increasing? When is it decreasing? Well, at this first part here, hey, look at, as I read from left to right, it's going down. This is doing something weird. What's up with that? It doesn't seem to be increasing or decreasing. This one's going down, it's decreasing. Then this one's going back up again. It's increasing. All right, hey, yeah, it's decreasing. When it's not doing either, it's called constant. And I did want to point that out, that like graphs can do that. It's neither increasing or decreasing. It's just at a constant rate. This one is decreasing, this one is increasing. So notice you can have straight lines, you can have curved lines, it doesn't really matter. So it's just as we read it from the left to the right, like what's it doing? So, and if you're having a hard time, like you might want to cover the graph with a piece of paper and reveal it by pulling that paper to the right. If the function's like going up as you're doing that, it's increasing. If it's going down as it's doing that, it's decreasing. Obviously, if we were in class, I would actually make you do this, but we are not. And again, what you're doing by doing that is you're kind of making the function dynamic in a sense instead of it just being a static image. As soon as you do that, most students' misconceptions about this just clear right up. So if you're having any hard time with that, you might want to cover your monitor with like a little sheet of paper and like pull the sheet of paper to the right across. And as it reveals, is the function going up or is it going down? So we are now going to trace when the function is increasing in green, and then trace the function g of x is decreasing in blue. So hey, look at this. It's increasing here. It's going up. And it's increasing here. And then it is decreasing here. And decreasing here. So notice that. Notice that these are in different places than we put the positive and negative stuff. Notice. Yeah, so it's increasing from here to here, decreasing here, increasing from here to here, and decreasing here. So increasing from -2 to 0, decreasing from 0 to 4. Notice that I'm reading these only with my x values. I am not using my y values on this because my increasing, decreasing intervals and my positive, negative intervals, the only thing that matters is the x intervals. And then I'm increasing from 4 all the way to, what is that, 12? And then decreasing again from 12 to 14. So my increasing domains Again, that's this one, and so that would be from -2 to 0, and from 4 to 12. And then in set notation, notice, for those of you wondering what the 0 is, remember it's this 0, the x0, not the 2 that goes with the y, because we only do these on x values. All right? And then in set notation, that'd be -2 upper is less than x is less than 0, or 4 less than x less than 12. But we read that as x is between -2 and 0, or x is between 4 and 12. Those are the intervals on which f of x is increasing. Now, for our decreasing intervals. There are 2. Again, that's from 0 to 4, and from 12 to 14. And I would write that as x is between 0 and 4, or between 12 and 14. Oh, and actually, yeah, as I almost forgot last time, this should be a bracket because it's technically still decreasing there. All right. So what I want to do here is I'm going to sketch this with the increasing in green. The decreasing in the blue. All right, and then I'm also going to layer the when it's positive in black on top. That's not very good, but you get the idea. And then negative in the red. And I just want to point out that notice they're not the same thing. That sounds really silly, or that might sound really silly, but they are different. You need to know they are connected. We will discover the connection between them in calculus. But right now, notice they are different. Delta Math is really going to work with you on this and make sure you understand the distinction between these. So let's go back to our stock market example. All right. And then look, when was it increasing or decreasing? Notice that it has a general decreasing trend here. All right. Hey, look at that. Look at that bad day. Hey, that was September 11th. Oh my gosh. All right. Then we have a slight general increase. And then this is during the financial collapse, 2007 to 2008, 2009. And then since then, we've had a generally an upward trend up until right here is when all the COVID stuff started happening. So decreasing, increasing, decreasing, increasing, generally, all right? Now, obviously, you could care about the little up days and down days, etc. But so, when's the stock market been doing well or not? Yeah. Or are stocks going up or stocks going down? It's funny, honestly, my uncle is a stockbroker, and he was a math major, and he was teasing me once about being a calculus teacher, and he called it calc useless. And yet I think it's funny is that I could then ask him if the market was up or down that day, which is actually kind of a calculus concept. He actually does use calculus every day. It doesn't look like the calculus he learned in math class, which is kind of interesting. But yeah, real world example. Is the market up or down? A wee bit of calculus. So try the next Go formative examples or problems.